Today we're just going to look at translating and reflecting curves. So it's something we have seen earlier this year. So we're just going to look at that today, so then we can move on and look at some other ideas tomorrow. So first of all, the translating of curves. And the first idea that we looked at was that idea of shifting. So a horizontal shift is when we replace the x with x minus h. So y becomes function x minus h. And so that means you move it left or right, depending on whether h is positive or negative h units. And if you're unsure, just solve x minus h equals 0. So that will tell you where it's been shifted to. And then the vertical one, similar thing, but now it's the y value you're changing because it's a vertical shift. So replace the y with y minus k. And so we get y minus k as function x. Although with that sort of one, we probably normally see it with the k moved to the right-hand side. So y equals function x plus k. But it's still the same idea. Whatever the shift is, you group it with that pronumeral. So horizontal, well, it's the x coordinates that define horizontal. So the shift's grouped with the x value. And vertical, well, it's the y value that controls the vertical. So it's grouped with the y value. And again, if you're unsure, well then just solve y minus k equals 0 and that'll tell you where it's gone to. So something like this. We see x minus 3 all squared plus 4. So we've completed the square on our quadratic and we've got it into this format. So we see that the basic curve is our parabola, y equals x squared. But we've got some shifts happening. So the first shift I'm looking at is the horizontal one. And I notice it's minus 3. So I've shifted it right 3 units. What makes x minus 3 equal to 0? Oh, 3 does. So instead of that vertex being at 0, it's now over there at 3. But we've also got a vertical shift happening. So plus 4 means we're moving it up 4. So there's our new parabola, and the vertex is now at 3, 4. Something like this, which hopefully you recognize is a circle, because we've got both x squared and y squared. The coefficients are the same, they're both 1, so we know we've got a circle. So we complete the square on both the x and the y. So it becomes half the coefficient of x, well, half of 2 is 1, so x plus 1 squared. And then we'll get half the coefficient of y, which is negative 2, so y minus 2 squared. And on the right-hand side, we end up with 9. So there's the 4 that we've moved over, but we've added the 1 squared, and we've also added the negative 2 squared. So we get 9. So what is it? Just in case we don't see it straight away, well, we say, well, okay, it's the basic curve. X squared plus y squared is 9 in this case. We have a horizontal shift. We've moved it left 1 unit. And we have a vertical shift. We've moved it up 2 units. So the center of the circle is at minus 1, 2. And I tell you what, the other thing I should have done there, and I haven't done it, is mark in the radius, because I've got no sense of scale the way my one's drawn. So I should really be saying the radius of that is 3 units. Y is 2x squared plus 8x plus 5. So again, I want to complete the square, but I really hate completing the square when it's 2x squared. So the first thing I'm going to do is divide everything by 2. So now on the right-hand side, we've got x squared plus 4x plus 5 on 2. Complete the square. So half the coefficient of x is 2, so we have x plus 2 all squared, but that means I've now created the 4 squared. Now notice I've subtracted 4 instead of added 4 here, and that's because it's on the same side. I am not adding it to the other side of the equation. We end up with x plus 2 squared minus 3 on 2, but now I'll multiply back out by 2. So we've got 2 lots of x plus 2 squared minus 3. It's our parabola again. So the basic shape is our parabola. The curve gets steeper. This is to do with something called dilations, which actually we're going to look in a bit more detail tomorrow. But a dilation makes a curve steeper or shallower. And so in this case, it makes the curve steeper. So let's just make it steeper. Whoop, there we go. So it becomes a steeper parabola. We have a horizontal shift. So I move it left, negative 2. Well, move it to negative 2. I've actually moved it left 2 units. And then we've shifted it, well, in this case, down 3 units. So our vertex has moved to negative 2, negative 3. And there's a sketch of our parabola. Another idea that we looked at was reflecting curves. So vertical reflection, replace the x with the minus x, because again, it's the width you're changing. It's being flipped vertically. So the horizontal is what you're changing. So y equals function negative x, but that ends up reflecting in the y-axis. Now, interestingly, if you wanted to reflect in another line, so say it was the line x equals a, then what you do is replace the x with 2a minus x. And what that does, it combines a shift and a reflection all in one go. Let me show you with a picture. There's y equals function x. Now, if I flip it, there's y equals function negative x. It's been reflected in the y-axis. But now I'm going to shift it 2a units. What makes 2a minus x equal to 0? Well, 2a does. So we've shifted it to 2a. Have a look, though, at the original blue curve and where I've ended up with the red curve, and you'll see they are reflected, and it'll be right there in the middle. So at x equals a. You can save yourself some time if you have to reflect in x equals a, rather than doing, I'm going to do a reflection, then I'm going to do a shift, is straight away just replace it with 2a minus x, and that'll get you over there. Look, it's a really unusual sort of question, but, if you do get something like that, that's how you can handle it. Let's have a look at the horizontal reflection. We'll replace y with minus y. So again, the same idea. This time it's the y values we're dealing with, because when we reflect horizontally, it's the vertical values that change. So minus y is equal to function x, although we normally see it as y equals, so you might see it as y equals negative function x. So if the negative is grouped with the x, I know it's a vertical reflection, but if it's grouped with the function x, then it's a horizontal reflection. So that will reflect in the x-axis. Same sort of idea though. If you want to reflect in a different horizontal line, let's say y equals a, replace the y with 2a minus y. In other words, it becomes y equals 2a minus function x. Let's have a look at what happens. So here's function x, 2a minus function x. So I'll do the reflection. There's y equals minus function x. And then we shift it up 2a units. Have a look at the original blue curve and where the red curve has ended up, and you'll see the reflection there in the horizontal line, and it's in halfway between, so it's at y equals a. So again, that can save you some time if you notice it. Important thing, when you're doing both a reflection and a translation, always do the reflection before you do the translation. So it's like order of operations. So same sort of idea. We always do reflection before translation. Reflection in the origin. So that's where both of them have changed to negative, both the y and the x. Although if you make it y equals, you see it as minus function minus x. It ends up being a rotation of 180 degrees. The reason why is because if you look at it, you're satisfying the condition for an odd function. Remember, function negative x was equal to the negative of function x, so you could end up showing that, hey, that's what we've actually got here. So it's actually two reflections. First of all in the x-axis, then in the y-axis. Or in this case, you could do it the other way around. Let me show you with a picture. Here's y equals function x. Okay. Now, if I flip it, okay, get it right, which way that one's. That's flipped horizontally. So it's the y values that change. So we now have y equals minus function x. Now let's flip it vertically. Flip it vertically. So that's minus function minus x. Have a look at the original curve. Have a look at the final curve. And you'll see it's got that rotational symmetry of 180 degrees. Right, so we want to draw something like this. Minus x plus 1 cubed plus 2. So there's both a reflection and a translation happening here. We're going to shift it as well as reflect it. It's our basic cubic. There's a very, dodgy looking cubic. But there's the basic curve y equals x cubed. We do the reflection first. But the reflection in this case is grouped with the function, not the x. So therefore, it's reflected in the x-axis. It's the y values we're changing. So there we go. Let's reflect that. Now let's take care of the shift. We have a horizontal shift. x plus 1, what makes that equal to 0? -1 does. So we're going to shift it to the left 1 unit. And then we also have a vertical shift. We're going up 2 units. And so there's our cubic. And what was originally the origin there, or the rotation point, is now at -1, 2. Y equals -2 to the power of minus x. So this is one where both the x has been made negative and the function's been made negative as well. So there's the basic curve, y equals 2 to the power of x, but we now have the x value being negative and the whole function being negative as well. Rotational symmetry. We've got reflection in the origin. So let's rotate this 180 degrees, and there it is, down the bottom there. Okay, so exercise 3G is looking at our translations and our reflections.